Hi madam, this is M. Mahesha from Triple department and my topic is drift currents. Drift currents. Introduction to drift currents. Drift currents are electric currents caused by the movement of charged particles in a conductive material. They occur in both solid conductors and in electrolytes. Drift currents are essential for the operation of electronic devices. Charged particles in drift currents. Drift currents are primarily caused by the movements of electrons in conductive materials. In electrolytes, drift currents are caused by the movement of positive and negative ions. The movement of charged particles creates an electric field that drives the drift current. Diagram: hole flow of electrons, flow of holes, free electron, voltage, positive, negative. Factors affecting drift currents. The magnitude of drift currents depend on the concentration of charged particles and their mobility. Temperature affects drift currents by influencing the speed at which charged particles move. The presence of impurities or defects in the conductive material can also affect drift currents. Factors affecting drift: spray characteristics, equipment and application, chemical formulation, drop size, evaporation, nozzle type, nozzle size, nozzle pressure, height of release, air movement, direction and velocity, temperature and humidity, air stability, inversions, topography. Drift velocity. Drift velocity refers to the average velocity of charged particles in a drift current. It is influenced by the electric field strength and the mobility of the charged particles. Drift velocity is usually much slower than the speed at which individual charged particles move. Current and drift velocity. Definition is a measurement of the amount of charge passing by a point per unit of time. It is a scalar. Variable I, unit A ampere. Equation I is equal to Q by T. There are a few variables that can affect the size of the current in a traditional circuit where electrons are flowing. They are summarized in the second equation for current. I is equal to NaVq, charge of each charge carrier moving through material, usually electrons. Correct current electrons per m cube in the material, cross sectional area of material, drift velocity of the charges in the material. Ohm's law and drift currents. Ohm's law relates the drift current to be applied electric field and the conductivity of the material. It states that the drift current is directly proportional to the electric field and inversely proportional to the conductivity. Ohm's law is a fundamental principle used to understand and analyze the behavior of drift currents. Ohm's law: V is equal to IR, R is equal to V by I is equal to V by R. Application of drift currents. Drift currents are crucial in the operation of electronic devices such as transistors and diodes. They enable the flow of electric current through conductive paths circuits. Drift currents are also used in various technologies including semiconductors and electrolyte cells. Drift and diffusion current. Original depletion region: P side, N side. P side, negative connection to negative terminal. N side, positive connection to positive terminal. N side, vaccines attract toward negative holes. Lower concentration. P-dense depletion region: electrons attract towards positive terminal electrons. Drift current versus diffusion currents. Drift currents and diffusion currents are two types of electric currents in conductive material. Drift currents are caused by the movement of charged particles due to an electric field. Diffusion currents are caused by the movement of charged particles due to differences in their concentrations. Drift current in semiconductors. In semiconductors, drift currents occur due to the movement of electrons and holes. The behavior of drift currents in semiconductors is crucial for the operation of devices like transistors. The control of drift current is essential for regulating the flow of current in semiconductor devices. Whole flow of electrons, flow of holes, free electrons, positive negative voltage. Drift currents in electrolyte. In electrolytes, drift currents occur due to the movement of positive and negative ions. These currents play a significant role in various electrochemical processes including electrolysis. The ability to control and manipulate drift currents in electrolytes is important for applications such as battery technology. DC current, cathode, cation, electrolyte, anode, anion. Summary of drift currents. Drift currents are electric currents caused by the movement of charged particles in conductive materials. They are influenced by factors such as possible concentration, mobility, temperature, and impurities. Drift currents are essential for the operation of electronic devices and have various applications in both solid conductors and electrolytes. Schematic representation source of direct current. First battery is disconnected, second battery locked to an external resistance or third mode of short current. References: Smith J. 2015, Introduction to Drift Currents, Journal of Electrical Engineering, 25 of 2, 15 to 28. DOEA 2019, Factors Affecting Drift Currents in Solid Conductors, Solid State Physics Review, 42 of 3, 123 to 135. Johnson B. 2020, Drift Currents in Electrolytes Applications in Battery Technology, Journal of Electrochemical Science, 10 of 4, 89 to 102.